In order to determine the initial basic feasible solutions for a transportation problem, there are three different methods. The difference among these three methods is the quality of the initial basic feasible solution they produce. The northwest corner method is easier, quick, and do not involve too much of computation. In the northwest corner method, suppose this is the transportation table. So the values in the cells represent the unit cost, and here we have 1, 2, 3 sources, and we have 4 destinations. First row is the first source, means it will supply goods to the 4 different destinations. So here, say for example, we have supply, and 1, 2, 3 and 4 along the different columns, they are the demands of the 4 different destinations. So suppose this is the demand here. Suppose the demand for the first destination is 5, demand for the second destination is 15, for the third is 15, for the fourth is also 15. And suppose the supply of the first source is 15, second source is 25, and the third source is 10. Now we must keep in mind that the transportation problem should be balanced. So in order to check if the transportation problem is a balanced one or not, we will add up the demand and the supply, and they must be equal. So 5 plus 15 plus 15 plus 15 gives us 50, and 15 plus 25 plus 10 also gives us 50, which means that demand is equal to supply. Now for the northwest corner method, the first step is we select the first cell. So this is the first cell with the entry 10. Now what we do, we select the first cell and then allocate the maximum possible amount to that cell, and then adjust the demand and supply by subtracting the allocated amount. So here the first destination has a demand of 5 and the first source has a supply of 15. So we can allocate 5 to the first destination, and we will just cross this demand. Now out of the supply of 15, we are now left with 10, since we have supplied 5 to the first destination. Then we move on to the second destination. So when we move to the second destination again, the demand for second destination is 15, and the supply of the first source is 10 now. So the maximum that we can allocate is 10. So we will allocate 10 here, and the supply is complete for the first source, so we will cross this out, and we are left with the remaining demand of 5. This 5 we will get it from the, since the first source is completed, we will take the from the second source. So from the second source we can allocate 5 here, and the demand for the second destination is complete. Now since we have allocated 5 here, from the second source we subtract 5 from 25, so we are left with 20. Next we move on to the third destination. Now in the third destination the demand is 15, and the supply left is 20. So we can allocate 15 because 15 or the demand is less than the supply, and we will cross this out. So out of 20 we have allocated 15, so here we are left with 5. Then we move on to the fourth destination. Now in the fourth destination the demand is 15 and the supply of the second source is 5. So the maximum possible we can allocate is 5. And the remaining demand is 10. And since we have allocated 5 from the second source, so the second source is complete. So we have a remaining demand to be fulfilled of 10. We will come here and we will allocate 10. So the demand of 10 is complete here, and the third source had a supply of 10, so which is also complete. What we will do is we will take all these cells for which we have allocated the values, and we will multiply each of this with the unit cost. So we will multiply 5 into 10 and we will add each of them to get the total cost. So 5 into 10 plus 10 into 2 plus 5 into 7 plus 15 into 9 plus 5 into 20 plus 10 into 18. So the starting basic solution is given by the variables. If you go back and recall, we have allocated x11, x12, x22, x23, x24 and x34. So the different allocations are given here, and when we add them the associated cost is given to be 520. So this is the Northwest method.